three different AI providers, three different technical implementations, three different API formats, three different vendor logins, and no conversation persistence across them. So I got inspired by OpenAI's Responses API and decided to solve this problem by making my own library for everyone to use. Introducing Cortex, an open source library made by me. With the code I made, you don't need to worry about different environments or different implementations or response formats. Cortex does everything for you in the most easiest way. And what's unique about is that you can have all data localized on your database, whether you use open source models like Llama or proprietary models, just like how OpenAI does. And you can change models mid conversation depending upon which LLM you want to use, and full contextual awareness and persistence will be retained. So architecturally, here's how Cortex works under the hood. User sends a request to Cortex. Cortex routes it through model selection, OpenAI, Google, or Cohere, or Llama, or Gamma. The response flows through a persistence layers that supports Postgres, SQLite, or pure memory. Finally, it returns an OpenAI type response across all multi-LLM requests, any model, any storage. This is what breaks vendor lock-ins. The real magic is in the conversation persistence. So Cortex uses smart checkpointers. They detect your database type, handles thread continuity automatically, and ensures conversation survives across models. Previous response IDs link conversations together, just like how responses API work. Cortex adapt to your environment automatically. Local development, SQLite with full persistence. Docker, Postgres with customs checkpointers. Serverless, Postgres pooler connection with cross-session storage. Serverless without a database, memory saver without a warning. Every environment is handled. No configuration hell. Just import my library and you are good to go. Same code runs everywhere from laptop to production, and it can be used with any framework as I will just demonstrate right now. As you can see, the memory is retained. So let's start with a fresh Supabase and Next.js project. So I've installed the dependencies and I've created a fresh Supabase database. So I'm going to be using Gemini CLI to for quickly producing this application. It's a multi coaches application which provides information about different areas of life. So let's start with creating migration files. So I've provided the provided the prompt and it's working. So it has created the migration files. Now let's link these migration files to the Supabase database we just created. So it's been connected. Now let's apply these migrations. Okay, there's an error. So let's solve this error by Gemini. Let's let it do its work. So it has identified what the problem is and it's gonna solve it. It has solved it. So let's try it again. And yes, the migrations ran. We have all the coaches we need. They will be used to provide context to the LLMs as instructions. So now let's start making the page for this on React. So it is doing its thing. I'm providing it with prompts. So what I've noticed while with working with these AI agents is that in order for them to work the best, you need to provide them with the maximum context. So prompts are very important. You need to provide them with high quality prompts. So for prompting, I usually try to make a rough prompt and then enhance it using using maybe ChatGPT or Claude or even Gemini, and then provide it to the agent for it to work. So as you could see, we are using the transaction pooler connection, which is a serverless database connection, and this is Cortex deployed on AWS Lambda. Everything is in there. You just got to deploy it to GCP or AWS or Azure, and just use it with. You can use it with any framework. You just need to send API requests. The serverless function will work its magic and provide you with the entire functionality. So Cortex can work as a complete backend. It's designed to do this. It can work with any environment, whether it's AWS, whether it's Azure, whether it's GCP, whether it's your local environment, whether it's Docker. So right now I've told Gemini to create a pretty comprehensive API route to accommodate requests, and so we can pass it to a Lambda function, and now it's making the front end. It's making the components. Now let's try it out. So the server has been started. Okay, so see, it seems like we are facing some issues. So let's try to solve these using Gemini. We will just provide these logs to the IDE, and it will work its magic. You do need to be careful with the LLMs. They can sometimes do extra, so you cannot use them blindly. They are only LLMs are only as good as you are. So you have to control them. It's very important. So we're using Gemini 2.5. So the good thing about Gemini CLI is that it has a lot of context. It has a huge context window, unlike Claude or Gemini, unlike Claude or GPT. So it can you can use it for a lot huge code bases and really complicated tasks, since it retains so much context. So yes, so the problems have been fixed, and we have the server live, and this is our application. So you can see multiple coaches, multiple AI models. We can switch between them. So let's try it out. So my name is XYZ, and I'm 21 years old, and I make $1 million a year. Can you advise me, finance coach? So the request has so this request and response format is exactly like how OpenAI responses API is. So it's a complete replicate of OpenAI Responses API, but better. As you can see, the data, some database tables have been created automatically by Cortex, and so all of the data is localized, the request as well as responses. So we have gotten the response back, and a huge amount of information has been returned by Cortex. Now we're going to switch model to command. It's a coheres model. Okay, how much money I make, what's my age, and how much, and what is my name. So these questions, so it should retain. And the advice it has given us is finance related. So how responses work is that once instruction is provided to them, and when they that does not change unless you make a new thread. That is also being followed in Cortex. So it can even work as an assistance API. Pretty powerful. So I'm going to CloudWatch to see some logs. Seems like we are not really getting our previous response ID. It seems like Gemini has missed this implementation. So let's uh, let's try to fix this. So let's try with habits coach. So the previous response ID is null because this is a fresh thread. The PostgreSQL connection has been working. So what is my name? How much money do I make? And what is my age? Let's change model. Oh, there we go. We have the response. Automatically the response ID has been created by Cortex and passed, and voila, the persistence is there even across models. So let's send this prompt and see if persistence is stored. Let's use Gemini for this. So models are switching and persistence is there. Pretty comprehensive response. Let's try test its persistence again using GPT-4D Mini, and there we go. Persistence is uh, pretty clear. Very massively detailed logs, just like how an industrial scale API would be. So this library handles everything it handles, and this is just the version one, and this is completely open source. So you can even contribute to it. We can use open source LLMs. So open source LLMs can be used with uh, OpenAI responses API, but it's completely for free. This architecture is completely for free and no complexity. Very simple API on Next.js, just like five, 6 lines, and everything is handled by Cortex. This is the library. Do check it out. Do contribute to it. Uh, this is something which took a lot of time for me to make, and I'm super passionate about this, and I'm super proud of what I've made. And let's um, let's revolutionize AI together. So yeah,